Welcome to RadSchool. Today, we're going to clear up two of the most commonly confused terms in science, radiation and radioactivity. You've heard them, you've probably used them, but by the end of this, I promise you'll understand the crucial difference between them for good.
So let's start with a little riddle. What in the world does a hospital X-ray machine, our own sun, and a chunk of the element radium all have in common? They seem totally unrelated, right? But there is one fundamental concept that connects them all. And that common thread is radiation. Every single one of them involves radiation. That's the key. But what does that word actually mean? Let's tackle that first. When we talk about radiation, what are we really talking about? Well, the simplest way to picture it is just energy on the move.
Think about it like this. Radiation is just energy that's traveling from one place to another. It's shot out from a source, could be the sun, could be an X-ray tube, and it moves through space or even through things. It's the effect, it's the wave, it's the thing that's actually doing the traveling.
Okay, that makes sense. But it brings up the next obvious question, doesn't it? If radiation is the energy being sent out, well, what's doing the sending? What's the source? And that, my friends, brings us to our second key term, radioactivity.
See, radioactivity isn't the energy itself. It's the process. It's the phenomenon that happens inside an unstable atom that causes it to release that energy, which we call radiation, so it can settle down and become more stable.
You want the absolute best way to remember this? Think of a sneeze. You know that tickle in your nose, that feeling that's building up and just has to get out? That unstable, gotta do something feeling. That's radioactivity. And the sneeze itself, that sudden blast of energy that shoots out, that's the radiation. Radioactivity is the cause, radiation is the effect. It's the process versus the product. So why do some atoms get that tickle in the first place? Why are they unstable? To get that, we have to zoom way, way in, right into the tiny, tiny core of the atom. The nucleus.
A great way to think about it is something called nuclear claustrophobia. Seriously, imagine a really tiny room, just packed to the brim with people. It's crowded, everyone's bumping into each other, and there's a lot of tension. That's what it's like inside a heavy nucleus. There are just too many particles crammed into too small a space.
And inside that crowded room, there's a constant tug of war going on. On one side, you have the strong nuclear force. It's like a super powerful glue holding everything together. But it only works over really, really short distances. On the other side, you have the electric force, which is making all the positively charged protons try to push each other away. In a big, crowded nucleus, the particles get so far apart that the pushing away starts to win against the superglue. The only way to relieve that pressure is to kick something out to release that energy. Now, this might all seem a little abstract, but I promise you, understanding these concepts has had literal life and death consequences. And there is no story that illustrates this better than the tragic, true story of the Radium Girls. Back around World War I, young women were hired for what seemed like a dream job, painting the dials of watches with a new, magical, glow-in-the-dark paint. The key ingredient was radium. But within a few years, these healthy young women started getting sick with horrific, mysterious illnesses. It took years of investigation and a landmark court battle to uncover the awful truth. And here's the detail that sealed their fate. To get a sharp point on their brushes for the delicate painting, the women were told to lick the tips. Just think about that. They were told to put a paintbrush dipped in a radioactive substance into their mouths. They weren't just working near it, they were literally eating it. This horrific practice perfectly illustrates another absolutely vital distinction, the difference between irradiation and contamination. Irradiation is being exposed to the energy, the radiation, that a source gives off. You stand near an X-ray machine, it zaps you, you walk away, the exposure's over. Contamination, though, is when the actual radioactive stuff gets on you, or worse, in you. The source of the radiation is now physically attached to your body. The Radium Girls weren't just irradiated, they were horribly contaminated. They ingested the radium, and because it's chemically similar to calcium, their bodies deposited it into their bones. It became a permanent internal source of radiation, relentlessly bombarding their bodies from the inside out.
This is why knowing the difference isn't just academic, it's everything. Their story is an absolute tragedy, but the knowledge we gained from their sacrifice became the foundation for all modern radiological safety. It's what allows us to take something that can be so dangerous and turn it into a tool for incredible good.
And we should never forget the risks are real. A whole body dose of just 4 gray, that's the unit we use for absorbed radiation, is enough to be fatal for about half the people exposed to it. This stuff demands our respect.
But by respecting that power, by understanding it, look at the amazing things we've learned to do. We can date ancient artifacts, sterilize our food and medical tools, see inside the human body to diagnose disease, treat cancer, generate immense amounts of clean power, and even propel submarines. And speaking of safety, the actual data might shock you. If you look at the number of deaths per unit of energy created, nuclear power is statistically one of the safest sources we have. I mean, look at that chart. It is orders of magnitude safer than the fossil fuels we use every day. That shows what happens when knowledge and proper management are in charge.
And that leaves us with one final question to think about. What's the real danger here? Is it the radioactivity itself, or is it our ignorance about it? The story of the Radium Girls teaches us that the greatest hazard isn't the atom. It's not knowing what you're dealing with. Knowledge is what turns fear into respect, and what turns danger into progress. Welcome to RadSchool.